So let's start the today's session. So we're going to solve the English problem. So I already solved the first previous video of this question. So now let's move to the double English. What is so double English? Introduction to double English. So it's like a introduction, introduction of their okay. Double English. You have double English is more. It is a complex data structure. That means you have to go to the previous index or the next index, right? You can go previous index or the next index. That's it. And the singularities, you have to go only the forward, not to backward. But in this, you can go either forward or backward. So what the question? First question, insert the node before the head in W English. Let's see this question. What this question said that you given the head of the W list in the position P and the pointer K. Okay. Add a node with the value of X. We can form we have to check given the head of W English, a position P and integer X. Add the new node. Add a new node with the value of X at position P at the position just after the pth node. Okay, so you have given the position P, okay, and the head should be present. So you have to add you have to add first 4, 6, and the 5 after the secondary position. Okay, that means pth position, right? So you have to first travel to the pth position and taking the first taking like the previous and the next, right? Like we reached like current element and the previous element. Current element, previous element, it's 2. So current element and previous element, we have to add there. Okay, and in the for current element, okay, 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 fine. You have to do here. Mm, first you have to travel like a position from where. So first made a node like the current should be head and also a previous should be null, right? Now let's suppose you have to go like from the 0, you have to go pth position plus plus. Now the previous element should be current and current should be the current next, right? You have reached the position. Now you have reached the position like 0, 1 you have 1, and for the 2 you have, for the 0 you have here, and the for 0 next one. Let's go to 5 and previous is 2. Now we have to move forward. So it's like a like P is given to. So you have 2, 4, and 5. Now for the 0, you have reached here. Okay, you have reached its current 0. Now it's become 1. So here, current here. Now it's become 2. So current here and previous here. Okay. So now we have previous and the current. What we have to do? Just make a new node. Just make a new node. Just make a new node, like a node, new node, new node, new node, value of x. Now what? What to do? Previous. We have previous. So previous next, mm, previous next. Okay. Node next. Node, new, new, new node. Next. Next would be uh, what? Current and the and the and the and the and the previous next would be new node. Previous new next would be new node, new node, new node, and the new node. Previous would be like we are new node. Previous would be what? New node previous would be we have previous, right? So you have to take here another previous, like current node, current previous node, previous previous node, new node, and new node previous should be new node previous should be the previous one. Now the question arises, like if it is current is null, what we have to do? We make that like previous should be here and the current should be here and new node here. So previous dot next should be that new node next should be previous. New node should be the current and current next should be, if it is not null, current next should be current, previous should be new node. Okay, new node if it is not null, right? Right, right. If the current is present, so the current previous should be what? New node. Okay, current previous should be new node. Okay, we make that connection and new node should be the current. We make the connection. Now again we have a previous. Let's suppose previous. We come to previous. Now what we have to do? Previous and like previous. So we are the previous next should be the new node. Previous next should be the previous next should be the new node and the new node previous should be the and new node previous should be the previous one. So yeah, this is and return the head. Okay, I think this should pass all the test cases. Let's see this passes or giving the wrong answer. Yes, this passes first test cases. Let's see, because there is lots of edge cases in this the like in link list, right? So you have to make sure that all the edge cases, yes, this passes all the test cases. So this one. Now let's move the next question. Like delete the node, delete the head of the link list. Okay. Mm, Where do you where do you start? Where do you I think it's privacy. subscriber. So the next question is like delete the head of the W English, right? So let's see the question. So it's like a double linked list. Given the double linked list of size n, you have to delete the head of the linked list and return the new head. Okay, so you have to just delete the head, right? And nothing else, and return the new head. Okay, why delete the previous new head to the null and set the null note and delete the old head. Okay, this is good. Why is this? Why it is a tough problem? Not a tough problem because what we have to do? We have to just delete the head now. So let's suppose the head is like mm, what can you do? Let's make a current current head should be head, right? Let's move to the next. So what we have to do? If the if the current next if the current next is present, this should be the present, right? The current head next should be the present, not null. So you have to move forward. So current next next current head should be gone to the current next. Now now what you have to do? You have to just do like a current current head previous, like previous should be the null, null ptr, null ptr, and return the current head, current head. And then I delete the head. Like current current is not defined. Okay, sorry. Current current head. This one is this. Yeah, this all the very. Now let's move the next question. This all are easy. That reverse the double English. Yeah, this one is good question. Reverse the English. So what we have to do here? We have to just reverse the double English. Like given the node of the double English, you have to reverse the double English and return its head. Okay, so you can go either from the recursive code, because and other go iterative way, right? But way is a bit fast, so it might be possible that you don't know. So let's suppose we are going at a iterative way, like 3, 4, 5, sorry, 5 and 6. Now we are the current head. Now let's suppose you have to just make a connection, right? You have to take a previous, okay, previous. Now it's the previous, so this previous should be the null, current, previous, previous, current. What you have to do? You have to just reverse the process. Like how can you reverse the process? Like Previous, previous would be the why we are reversing the process? Like we have just to return the double index, move forward. So you can go and reverse the that much program. Can I can I do like that? What that like? No. You can't go like the three. You have three. So you this is next and previous this. Or I think you can go and return like that. Let's suppose what I'm trying to do. While head should be again. You are moving head is equal to head next, right? And return the head. You can't now. Like my output is 435. You can't do this like now. What you are trying to do? You are just moving forward and returning the five values. So this can't. Output difference is fully removed. Uh, your output is nothing here. Okay. What we have to do here? The relevant print the return and go forward and backward version. Okay. So we have to print, right? No. You have to do. So what we can do here? Previous or head. Previous head. Previous would be null. We have to print, right? No, I don't think so. We have to print now. This current now. So just why this one? Given the head of the W equals and this one 3, 4, 5. So we have to make a list or something, right? Yeah. Like 3. Next should be 5. That's like what we have to do. What we have to do here, 3, make a temp null and going to take current should be the element. Current should be the element. Okay. Got it. Got it. Now got it. You have to just reverse the number, right? Current and the previous. That means the temp because previous might be the ambiguous because that in this process the previous is taken. So we take a temp is equal to null and and the current should be the first head. pointing to the head. Now we are moving forward, so temp should be the current previous. Temp should be the current previous. That means this other or move forward. Or can you move forward? That's correct. Okay, temp should be this. Now current we are struggling as fast. Now current should move current previous previous. Okay, temp current previous and previous should be current next. So this should be this. Okay, okay, now I get it. What we have to do? Take a doubling list, right? So current previous should be um, storing the current next and the current next, right? And current next should be three. And we are four. Okay, four. And current next, current next, current next should be current previous should be that like we have like we have three, four, five, right? Three, four, and five. So it's a previous, it's a current and temp. So this storing this. Now we have previous, so you have to attach this. Current previous should be the current next, right? Like three, four, and five. This is the solution. Yes, this is solution. So what you have to do, like current previous should be marking that the current next previous current next should be the current previous. So we are initializing the next. We are current previous pointing to the next. Okay. Now current next should be what? Now temp. Current next should be temp. That means current next should be the current previous. Okay. Current next should be current previous. Now again. Now what? Now again. Current should be now where to move. Like where we can do. So where we can go like again like current previous, so we can go like a current previous because this is storing the current next one. Okay, okay. And if the temp is present, so you have to just head temp previous. Now let's solve it. How can we solve it? Node current should be the head and temp should be the null, right? Now what you have to do, like first travel all the way, like current should be present if it is not null. So temp should be pointing to the current previous we are storing, right? And current previous should be pointing to the current next, right? And the current next should be pointing the temp, right? Just swapping, just we are swapping, right? Just swapping the value and move move forward, like now we are moving forward using the current next, but the current, you can see that the current next is a store in current previous, so you have to move forward using current previous, right? Now what we have to do, like we reached from the point where to reach, mm, like three, so we are making like this, and current next should be the null, we are making null, yeah, null, it's a null. Now again we are making like this current previous, so 5 current previous should be making this. Now we have reached, so if the temp is present, What we have to do? Just take a head and temp dot previous we are initializing and returning to the head. All right. Yes, this should pass the test cases. Let's try to run. So this like the swiping the value, and in the last we are initializing the we are taking that means showing that the head value, right? So this is so now just move like current head. So this one good. Head temp null current null, and moving forward we are just trying to what we are just trying to swap the values like not swiping but make, breaking the breaking and the pointing the next like previous should be the we are pointing to the this one, and we will reach this. So this previous should be the like this previous should be making that this one. So you have to just we have reached to the temp. Now you have to just take the temp previous, like that's index is previous. So what we have to doing here, like let's suppose we have three, we have four, we have five. Now temp is null and the current is this. So what we are doing here, like current null. So let's take a imaginary address. So we are storing like current previous is null, and the current next, oh, sorry, current previous should be the current next. So it's a 200, it's a null. Again it's a current this is it's a 200. Now it's a 300. Now it's a 300, sorry, 200, and it's a null. Okay, now we have 300. Now what we can do here, like previous index would be current next, sorry, current previous should be the current next. Storing the current previous should be the current next. So we are storing like 200 here. We are making a connection like this. Now the current next should be null. Okay, this connection made. Now we will do the current again in the value of 5 4. Now current previous should be the temp. So it should be the 200 value. Now the current previous it's a 300. Now we are making the connection like here. Okay. Now current next should be the 200. Current next should be the 200. 200. Now move to forward. Now we are reached to current 300. Right. We reached to the 300. Now we have to just take like previous it's a null. So we making null. Now we have to move like current next. What should be the current next, right? If so, current next should be the null, but we are initializing here 300. Now we are making that connection. So if we make the connection, it's like a 4 and the 3, right? 3, 4, 5. So it's like 300, 200, and 100. Now it's a null. It's 100. Sorry, it's 200. It's 200. Previous, sorry, 100. And again it's a 300. Now it's a 200 and it's a null value. You have to just return the temp. Where is it? Yeah, I am the temp. Where I am. I am the 300 position. So where If it temp value is present, so temp value is like 300, we are 300. It is the 300 previous should be the null. Wait, you are returning the null value. This is some kind of joke. Oh, what a joke. Okay, so this one, temp, temp is here. Temp we are storing like a, like a, we are now, it's a null, so we are going to null. Temp here 30, 300, right? Oh, we are making a mistake, right? Uh, let's suppose we have 200, 100 address and value is 3. So one value is null and the other value is like 4 value has 200 address. So it's a 200. Now it's a 100. Now it's a 300. Again, it's a value 5. So it's a 200. Now it's a null. Now what we have to do? Just we have to just put like the, like, let's suppose, so we are taking the current and temp. So yes, we are storing that 200 value here. It's like a 200 value. So we making the connection from this to this. First of all, we have connection like this to this, but we are making like a connection from this, from here. Now next should be what? What should be the next? Next should be the null, because we are reversing, right? So it's like a 300, 200 and null, right? It is previous, it is next, and it is 100. Now we go into there. Now previous again we have temp equal to 100. Now we are making that 300. We are making the connection from there, and we are taking that previous to 100. Like we are taking the connection here. Good, good. Now again, what we have to do? Now we have reached to here. Now the previous should be the what? Previous should be the 200, right? Previous should be the 200. And now we do what we have to do. Just take like the previous and take a null value here. Okay, null value here. Like the previous and make 10, 20, and we go it out of null. So now the situation become like this. What? What situation become like? 4 null, 4 null, and 200 value. Okay, 4 null, 200 value. Now what is the 200 value? 200 value. This 200 value. This make the connection. Now previous like 300 value, 300 value, and the 100 value. Now this like this becomes the totally reverse. So next, now previous should be the, here previous should be the previous 200 and next should be the null. And what I am the in the temp position, right? I am the temp in the temp position. So where is the temp value? Temp value is 200, right? 200, that means where I am here is 3 position. We are returning 300. Yes. Now I got it. This is one. Now let's move the next question. We have solved the linked list and the medium problem of LL linked list. Now the question arises like middle value of linked list, right? What is this? We have to find the middle value of linked list. So we can use that first brute force approach, like first found the number of all the nodes and finding the middle one, right? Like we have 1 2 3 4 5, right? So the middle one is like 3, and we have 1 2 3 4 5 6. So 6, it's a 0 1 2 Okay, 0, 1, 2. Okay, so middle one, 0, 1, 2, 3. 6 divided by 2, it's 3. Yes, it's 4 deleted. And the 5 divided by 2 is 2. So 0, 1, 2 divided. That means this is the zero index concept, right? So first approach is like you have to count all the number and delete the middle one, right? And the second approach is like, can I use like fast and slow pointer? Like, if you use the fast and slow approach, like 1, 2, 3, 4, and 5. So slow should be the null and fast should be the current head. So next to next, fast here, slow here. Next should be next, fast, slow here. Okay. Now again 2, 3, 4, 5, 6. So slow should be the null and next should be here and slow here, current here. Now next should be here, current here. Now next can't we go here? So it's not like we can use the fast and slow approach, right? We have to just take like the same like approach, like it's 1, 2, 3, 4, 5, 6. So we can go like here to here, and slow here. Now we can go here, slow here. Now we can go here, slow here. Now we can go here. No, slow approach, fast approach. 1, 2, 3, 4, 5, 6. First approach with this here, slow, and the fast should be the 3. Now fast set with the 5, and this should be the here. Now we can't go outside. Let's suppose we can go outside, so we can risk it. Okay, so next should be the element, right? 1, 2, 3. Slow, fast should be here, and slow here. Next should be the element. Yeah, we can use the we can use the fast approach, right? Like fast and slow approach. Let's proceed with the fast and slow pointer, right? Let's suppose we take a list node, list node, list node. One fast should be the head, and the list node and slow should be the null PTR, right? Now what we have to do? Just travel, right? Just travel. You have to just travel. You can delete like that. So head, delete. You are the index. What we can do? Like current, like fast. Should be the present, right? So what we can do? Like slow should be the slow should be the what? Fast, no, not a fast. Slow should be the slow should be yeah. No, no, no. You can't go like. Yeah, I can go like a one slow and fast. Make both 2, 3, 4, 5, 6. This goes this, 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 this goes this. 1, 2, 3, 4. Slow and fast. So fast go here, slow go here. Right. So fast go outside, slow goes here. So it's like 4 is equal to 4, 4, 0, 1, 2. Yeah, you can go. Like mark it like this also head. So slow is slow, slow is slow. Next, and the fast should be the fast, fast. Next should be the next. Right. We we reach to the destination, right? Slow is pointing to the middle value of the list. Right. Slow is pointing to the middle value of the list. So just you have to make a connection. Like okay, so you have to also check like previous value or the next previous index or the next value. So take another approve, take another like previous should be the null PTR. What we have to do? Just moving from the slow, uh, just slow. So this is good. Now what we have to do? Like just take a node, current, current, future. Take a future. What is future? Future should be the slow dot next. It is the future in list node, and we got the previous and future and slow. We have to delete the slow, right? So what we have to do here, just take the like previous element should be the, so just take the previous next should be the pointing to the future, right? Just that's it. Are you sure this is right? I think this is right. Like future, we are standing on the, so, and just we have to just make like the, and slow next, delete slow next. I sure. Yes. So why we are taking this? Just take now slow next and delete slow and return the head. Ah, previous null PTR, null PTR. Can I do like that deleting? So it's not pointing, right? Null PTR, right this. Yeah, delete the slow pointer. Member access list node not, while the past next to be the present. Okay, okay. And also, and or past should be the present, right? Past should be the present. Like why this giving 3.2? Okay, you have to delete 342. Okay, given is return the middle node of the link. Okay. What? Just nothing. Just return the slow. This question as this. You have to not to delete, but you have to just return the middle value, right? This approach pass the test cases. Now let's move the next question. Right, reverse the linked list iterative way. I just solved the reverse the linked list, right? Now let's again solve it out. Like given the linked list, you have to just return the, okay, this is the singly linked list. So what we have to do? We have to take a previous value as the correct value, right? So we have 1, 2, 3, 4, 5, 6. Like we have 1, 2, 3, 4, and 5. Now we're taking the previous value, it null, and the current value should be head. Not now what we are going to do. This should be this. So this should be this. Now, like current next. This should be that current next. Now take a future, and the current next will be maintaining the previous. So current next should be maintained at the previous. Okay, previous. It's a null, and we reach to the future, right? Future is this. Okay. Now current should be the future, current, and future should be the current next. This future. Now we make like this is null. This is null. Now this next should be maintaining the temp. Okay. So what? While while the future is present, like future is present, future, future, future is present. You have to just move the future, right? Future to next is present. Yes, future is present. You future to next present. So previous should be the current, and current should be the future, and future should be the next dot this. And again, what we have to do? Just current dot next should be the previous. Okay, current next should be the previous. This one is good. Now let's suppose we have 1, 2, 3, 4, 5. This. So future should be this, current, temp, temp and current should be null. So future this should be this. Now we are traveling. We are taking three pointer, right? Just go to future again. Now current we have this. So current null. So it's one. So it's null. Null. It's pointing to null. Pointing null. Now we have to current two. So it's taking like a previous one. So previous. So two, one, future three. Now temp is here and temp. Hmm. Okay. Okay. Now we nothing this. Now future we read this. Current this. Now with this. Now future is here. Let's the current is here. Current is not present. So you have to return the future value. Now let's suppose make a three pointer approach, right? Three like list 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 node. First you have to take the temp like a previous null value and take a current null value and take a what you have to take like a future take a future value like what head. Now while future value should be present future future what we have to do just take time equal to current. The current should be the future and future should be the future future next. Okay. Now now take like the current next should be the pre- next should be the previous right and just return the what future. Are you sure this future is right? We are returning null ptr current future what list node list node list node. Okay. Like current should be the current temp should be okay not a temp but a previous 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 previous. Okay. Now and next should be the previous index maintaining the index. That's it. This is not giving right answer. Okay, this returning only na null value. So what we have to do? Like current. Current should be the to read the null value na. Okay. So you have to just return the. I think you have to just return the current value, right? Yeah, because the future is pointing to the next, so it go out of the bound. Yes, this is solved. Now let's move the next question. Right, reverse the W link list LL. That means link list. So I solved just now. I just solved it. I just I think same problem is given. Detect a loop in link list. Oh, this one is good problem. What we have to do here? Given the link list, head determine the link list. You can use the brute force approach like all the all the parameters should be the continuous next pointer copy use position is used denote the next pointer position not determined return to linked list. So what position should be that 1 2 3 positive what the given the linked list and determine the position of the list from linked list. Determine if the cycle in layer otherwise return false. Why is this given the position? No, there is no position. I think uh, the position. So I think the position is like the linked list cycle. So given the head of the binary tree, sorry, you have to given a linked list head. So you have to detect the cycle, right? So what can you can use the fast and slow pointer, right? Like how can we approach using the fast pointer? So which course at BTech Now linked list given that. So now we have to like what to do. Use the fast pointer and slow pointer, right? 0, 4, -4, and so slow should be here. Fast should be matched. Fast should be the here, and slow is here. Fast should be the fast should be the fast should be that. So if the slow and fast match, so you have to return true. Like the slow is here and the fast is here. Okay. Now what we have to do? Just move forward. You have to just return the move forward. Yes, return true. What we have to do? Just take a list node. Uh, like a list node. Okay. You have to take a slow pointer like a null ptr and the sorry not a null ptr like you have to take a head, right? Head. Okay, head and the slow and the fast should be the head. Now let's what we have to do. Like we have to check while the fast next should be the present, right? Fast next should be the present. You have to just matching, right? What we have to match like 1, 2, 3, 4. There is no cycle present here. So slow and fast. Yes, here. Okay. Fast present should be the present. Fast should be present and fast next should be the present. Next should be present. This one is good, but let's suppose the slow should be the what? Let's suppose the slow. First we are making like the slow should be the slow here going to here. Like the slow should be going to the third, third 0 and -4. So first slow is here and the fast is here. Fast should be moving to next here and slow should be moving here. Now again the fast should be moving again here so we can get the fast and slow in that for you. You have to just move first. First the first like fast. You have to just move the fast. Fast should be the fast. Next should be the next. Uh, you have to take like a fast, 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 next, and next should be the present. Right. This should all the present. Now, slow, if slow is equal to fast, you have to return the true. Else you are slow minus next, and otherwise you have to return the output. Let's see this passes all the test cases or not. So it's giving the right answer, but let's we have to match like one test case by my side. No, just try to run it. Let's see given the right answer or the wrong answer. So it passes all the test cases, right? So this one is oh sorry. This one is detecting like a loop, linked list to medium problem. Now detect it, then find the starting point of the LL. Find the starting point in LL. What is this? What this question said? Linked list cycle 2. Given the linked list, return the node where the cycle began. Okay. So what we have to do is you have to just again you have to find the node and you have to find the starting node, right? Not the What? Int, not detect cycle. It's like the given list position of, I think, given cycle. There is no cycle, so you have to return null. Okay. What we have to do here, like first, like 3, 2, 0, -4, 2. So let's suppose we have slow and the fast we gain. If the slow and equal to fast, what do you have to do? You have to again initialize like the fast slow here and fast here. Okay, okay. No, fast here. So it's the slow here, and from the slow you have to just return. Let's build the again data structure like let's build a loop. Let's build a loop like a 3, 4, 5. Yeah, 5, 6, now 7, 8, and this could be this. Now what we have to do? Just slow pointer and fast pointer. So we are approaching like a uh, fast should be here, slow should be here, S and fast. Now again, fast should be the here, fast should be the here, fast should be the here, and slow is in here. Now again the fast should be the here, and slow should be here. Now again the fast should be the here. So it's finding the slow and fast. Slow and fast. We found the slow and fast. Now making the slow at a first position, head, and this. So we're making like here first, slow should be here. Now again we are making here, slow should be here. So no, not that this must not. Hmm. Detect the loop is good. What we have to do here now? Like now, what we have to do? Like how can we approach like fast approach and slow approach? Like I think the fast and slow is not good. Like we are approaching right in solution, right? So we are coming to here. Now fast should be here. Okay. Slow is here. Fast should be here. Now again the slow is here. Slow is here. And again the fast should be where? Fast should be the here. Fast here. Now slow is here. Fast should be the one two. Fast should be here. Now slow is here. Slow is here. Now fast should be the here. Now slow is here. So fast should be the here. Now we get it. Both get it. Now we have fast here. Now slow should be here. Okay. Now the fast should be this. Again this. Read this here. Again read here. Fast. Read this here. Right. Now fast should be the fast food goes to 6. 6 we have reached the 6, right? 6. Okay, wait. This matching this. So this fast slow over here. And again we have to just move it out like right the data structure, right? Move we have to move like so fast. We are matching fast here, so we have to just move to forward like from the next previous. So it's here. Now again what? Like we have to just fast and slow. We have to just move like this. We are reached here. Now fast would be the head. Now just from here we have fast. Now should be slow. Now fast should be the here. Now next slow here. Now should be the here. Now next should be the here. So it's can't get right. So like what we have to do here? In this cycle, so we have to take a like take a take a node node. What node should be the first slow, should be the head. Again the list fast should be the head. Now you have to just check first the loop, like while, right? You have to just take like fast should be the present, and fast 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 next should be the present. Now what we have to do, like slow slow next, and the fast should be the fast boot, like next and next. Okay. Like if the slow equal to fast, you have to just do nothing, right? You have to do nothing, like while the head is not equal to the slow slow is equal to okay. So, so head should be the, like head should be the head next next, and slow should be the slow slow next, right? And again we get it. Now return the true value, return the head value, return the head value, and if not is found, you have to just return the null value. ना तुका you कहना बनता. Yeah, this is good. You can use the detecting loop for same approach. Like you have to you can use same approach, like here copy from here and just fit. I solved it. Just 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 remove this one and return true and return false. Right. You have to just do it. Now let's, like sorry, check the length of the loop. You have to just do nothing. Find the length of the loop. You all got it, right? So now what we have to do, like find the, given the head of the list where the linked list. First you have to tell that the linked list should be contained linked list. Okay. Yes. If the head and not, we have to just move from the head to count. What you have to do? First, you have to find that yes, the head should be present. Now, let's suppose the head slow and fast matched. Now, you have to just move while the fast next. Sorry, fast is equal to fast next, and while the slow and fast not equal to fast, move one and count the CNT. This even is good. You have to do, right. So, what we have to do first? If there is no position, that means you have to know. Just take a node, like what? Just take a fast approach. Fast should be head, and slow should be the head, should be the head. Now let's suppose while fast and then fast next should be present. Now what we have to do? Like slow, slow, slow next, and fast next dot next. Good. If the slope is equal to fast, you have to just take a CNT. It should be 0 and the fast should be move forward. Next, so it should be 1 now. It should be 1. No, no, not a 1. Let's take a 0. While while slope is not equal to fast, fast. So increase the CNT. So it should be, I think it should be 1. Fast CNT should be increased like 2 and fast, fast. Next, and you have to just return the CNT value, else you have to just return the 0 value, right? Yes, this one passes. Now let's move to the this question is good. What this question said, like palindrome link list, right? So given the head of the link list, return true if it is palindrome or not. Okay. So what we have to do? Like, can I use the recursive tree? Like, no, no, not the recursive. We can use the brute force approach, like a store in a vector and then checking. But I'm not going to solve using brute force because most of the interview questions they only asked that you know the brute force, but they ask code for the optimal code, right? They don't they don't allow you to write the brute force code. Okay, so I'm going to solve using the optimal way. Like, what is the optimal way? So it's the one, 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 one. Right. Now, what is the here? If we okay, so this is previous. We can't go right. It's the head should be here. Okay, if we go over here, it's checking like if it is equal. Yes, it is equal. We can't go the previous, right? We can't go to the previous. We can't go to the previous. So what can we do, right? How can we approach this? If you can't go to in English, you can't go to the. So you have to just take it out like that much, like the 1. You have to just reach to the middle value, right? Just take reach to the middle value, like the middle value. Okay, middle value. So this should be the this should be again. You can't go to the previous. Again, you can't go to the previous. What can you do? If you can't go to the previous, you have to use the brute force approach, right? So can I use the recursive way? Like no, you can't use, you can use the recursive way, but as you can get the head, I don't think so. So can I reverse the link list and again checking like with the right, like made a helper function which reverse the link list and we have reversed the link list and we can check like out like what we have to do like 1 2 2 1. So this is the original and free and the reverse should be the 1 2 2 2. So it should be the same like so it's a false. Can I use? Yeah, you can use like first write up reverse the link list solution like made a helper function. What um why made a helper function? Just reverse. in this iterative way. Why call the helper? No, helper function is good. Okay. So list node, helper function, list node should be uh, header. Now what we have to do? You have to just reverse the link. So what? Just reverse the link list, right? List. I already made. I already solved the list, so I'm not going to again solve the reverse one. So we have to just reverse the linked list question. I solved this question, right? Just copy from here and just paste here. Now take a list node, reverse, 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 river head should be helper, helper function, and call the head. Now, now we have both like while reverse, sorry, reverse, sorry, river head and head is present. If the river head head data is not equal to the head, just return to the false. Return the false, right? And river head should be the river next. Sorry, river head and next this, and head should be the head. Return true. Just solve the problem. Ah, data should be right now. Data should be right. Value, value. Answer why? It the reversing is not true. Like one, one, two, one, 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 two, one. Okay, 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 okay. We have made a mistake. We had made a mistake. Like you have to just check that the middle value. You have to check like the middle value. Should be middle value, not fully value, but head value. Like in this approach, we are making a mistake. Like we are checking a complete, so we have to not check the complete. One one two one one two. Huh? One one. Why? Why this? Why this? Huh? Reversing should be no present now. Why should giving this one two one? This is the sometime of two. Why? It's not reversing the value, right? This sometimes like flavor is not equal to head value, so return false. So should be the this is the head, this is the river, so it's a true. It's a false. So just return false now. Like one, two, one, 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 two, one. Okay. Why this is giving the wrong answer? Why? Why? If the reverse function is not it, let's debug it. How can we debug? See out, see out reverse head value space head value handle. Sorry, handle. Let's debug it. Why this? Okay, sorry. I am taking that. I'm not making it. Okay, you are making the head cases. So one. Why? One? Only one? Hmm? Is not equal to head. Huh? What the fuck is this? Why is that error? Huh? We have to travel all the way, na? So why one only? This should be all present, right? Oh, so why this is giving to us? This is the pointer approach failed, not a fail. Reverse node head helper. Head should be okay. This call the helper function. This made a head one equal to head and take the head one, take the head one, take the head one, take the head one, take the head one. Now let's see. Oh, again one. Head should be next. Head we should be that. Oh, why this? Like, is there any approach like I am traveling? Is not to head one return to false. We are traveling right. So why one giving only, not the one two output is different code. This is code. Hmm? Sorry. Just keep it here. That's it. Huh? Why this? For this, you have to just one. Okay, so reverse head. Next, is the English is not moving forward or not? What to do? List node, helper, list node, reverse the value and calling from that and moving next forward. What is this? Why this is giving the wrong? Like head node, reverse while both are present. Both are present. We have to move forward. Why this giving the wrong answer, bro? Why? Why this giving the wrong answer? Head pointer village. Head. Previous should be signed right? Reverse function is good now. Yes. Okay. So I think na if we are calling from here, so it's reverse the complete all function, right? Mm. So so we have to do like locally. Like what we have to do here. Sorry, I think this decorrect all the values. So what we have to do here, like we have to just find the first find the we have to just find the middle value, right? And first first find the middle value. First find the middle value. Then we have to just reverse call when function. Okay, just just we are the calling the helper function, but it reverse all the function, right? It reversing all the values. So what we have to do? We have to just call the sorry. So like we can use the list node row head and the path to be through head, right? Now what we have to do here? What? Yeah. While nothing करे बिना दानी है. So just move to next, right? And slow should be slow, slow next, and fast should be fast. It's equal to fast, fast next should be the next. This one is good. We find the reverse function. Now let's take a node. First half half like a half like a head, and the second half should be list node, and second half should be sorry second half should be what? Half should be call the helper function, and with the helper function with with flow. This reverse the first half and second half. Now while the second half is present. Okay. While the second half is present, while the second half and the first half. No, the first half is always present, right? Yes, while the second half is present, you have to just what to do, what to do, what to do, what to do. If the second half data is not equal to the first first half data value, just return the true value, true, no, sorry, false value. And moving forward, first half, first half should be moving forward. First half should be the moving forward. Second half should be second half, second half, next, right? Okay, now and then return the return the true value. Let's see this passes all the test cases or not. Yes, passes all the test cases. Let's try to submit it out. Why this Colaveri? Yes, this passes. So they switch. Now next, let's move to next question. Average order and event list. So what is this question? Segregate. Okay, so we can use the brute force approach here. What is this? Given the head of the linked list, group all the node with okay event indices together, following by the node with the event. Okay, so 1 3. Okay, 1 3 5 2 4 5. Okay, so what we have to do? 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 We can just swap it out. Take, 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 take. No, 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 no. Just ready one. Okay. Just swap it out. Swap. Swap. 2 4. I am good. I am good boy. I am good boy. I am good boy. I can't do it. No. There is this question not solved with the. So you must solve in zero extra space and complexity and okay. So don't use the vector. The question suggests that don't use the extra space. That means you have don't use the brute force approach. So without for using the brute force approach, you have to use. So what we can do here? What we have to do here, like what can do here? Like event index should be odd index one. I'm odd index. So the video. So what we can do here? Bundling without extra space. One should be one. There is no two. Now 2 and 3. 2 3. This swapping. 2 3 1. Now we have 5. Like 2 3 1 5. Okay. Middle value 2 3 1 5. Now again, just reverse it. We have 6. No, the 5 is 5. Yes. So 6 4 7. Reverse it. 7 7 4 6. 7 is 7. Reverse. Now we have 314, 314, 1, 1, 2, 3, 4. What we have to do here, like we can use the brute force approach, like storing in a vector and doing that sit. But the question say that you must solve the problem in no extra with log n 1. That means the constant space and the sample complexity. What we can do here, like if we take the first middle and reversing the number like 1, so it's wrong place, wrong place. So it's a 3 and 1. Now again the 5, so it's like a 1, 2, 3, 4, 5 it, 5 it, so 4, 1, 2, 3, 4. So now what we have to do? Okay. Now if we take the 6, 6, 5, 7, 6, and the 8, 8. So, so we have to do like what? Use like 2, 1, 3, 5, 6, 4, and 7. So if we are storing like 1, 2, 3, 4, 5, 6, 7. So 1 is correct. So 1 from 2 and next. So it's the reverse. 2 now 4. Both is good. Now again go to here. Now find like 6, 4, 7. So this sorry 5, 5, 6, 4, 7. So this and this 1, 2, 3, 4. So this will be this. Now we have to just swap it out like no, no, no. 1, 2, 3, 4. It's a 4. 1, 2, 3, 4. Not a 4, but a 4. 4. It's a 4. Now it's this. So just swap it out. 2, 3, 1, 5, 6. 6. Sorry. 6, 5. 4, 7. Okay, 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 okay. What we have to do here? 3, 5, 6, 4, 7. Just to prove you are standing on this position. So this is right. So you have to write this and this is not. This is this and this is wrong. What we have to do, what you have to do, just swap the value. It becomes 2, 3, 1, 5. 1, 2, 3, 4, 4, 5, 6, and 7. Now this could be moved out. 7 indexes. This could be moved, right? This could be moved. Where to move? And just I don't think, I don't think, I don't think, I don't think, I don't think. Can I use the pointer approach? 5, 6, 4, 7. The pointing is here, so it's a swap. Now move to here, move to here. So it's the odd index. Previous should be there. So it's move to, sorry, 3, 1. Position is here. I move to here. It's odd. It's odd. It's Take it here. Hmm. Okay. So six, it's six. So yeah, we can use the double point. That means the pointing like element, right? How can we use like three? We have present three, one, two, three. If it is only left, you have to just snap and the reverse like add list node, list node, list node. What list node? What position should be? What head? Okay, and the list node. What current? What head? Okay, head. Okay. Anything? Any other thing? No. Okay. Oh, the sun. Take a take a chill pill. Like code is equal to one. It's equal to one. While the current. So if the odd is if the odd is odd, you have to just nothing to do. Swap. What value? What value? Position. Well, and the position and the current. Well, and move the position. It's equal to position dot next. Okay, and move the current, current dot, current dot next, and increase the odd plus, and just return the return the head. Let's see, this passes all the test cases or not. Oh, this failed all the test cases. Why? Like it's one. At last position, you have to just say it like okay. We're just not stopping in the last position, right? One, one. You have thought. Move to next position in three. Now current position is this, so it's become two. So you can't swap it. Now again, what become three? It's what become three. Now you have to swap. So just one, three, two, and position is here. Position is here. Right? Position is here. This one correct. Now position is here, and current should be what? Nah, take a one, two, three, four, five. Current should be this. Position should be this. Now if we or you have to the position should be here and the current should be here, so it's even, so you have to move forward. Position should be here, if current should be here, you just swap it out and two, and the position should be here, current should be here, so it's the current should be here. Now you have to just push it out like, and the final structure you have to just swap it out. I think, yeah. So you have to just swap it out like what position should be, what position should be where, position should be swap to the next, right? Position should be like we reached from where we reached I think position value and position value next. Are you sure? Yeah, I am sure position should be here. I'm sure position should be here. So in the final version, just swap the position, dot value, and position dot next value. Position should be next value. No, no, come on here. Again. Huh? Okay. So we are making mistake here, right? Mhm. Let let me see. Let me see. like 4 and 5. This one is good. 4 and 5. So take a previous, right? Take a previous. What is previous index should be? Where should be the previous? Previous should be the previous one. This this. You have to just start the previous. Take a previous like current. Take a previous like 1, 2, 3, 4, 5. The current should be previous. It's a previous. It's a previous. It's a previous. It's a previous. Just if the current next is present, then we have to previous for current. Current previous present, so you have to take a previous, right? You have to take a previous, take a previous null ptr is the current next is present, then the previous should be the current, right? And just swap the previous value and previous value, right? Swap the previous next value. Referencing. I think this might be the I, this might be the giving the wrong answer. Let's try to see. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. Okay. Not taking that much. Mm, I'm brute force. I'm brute force. We have to check not the previous but the position value. We have to check like the position value, right? Position should be not the position 4, 5. Like like 1, 3, 5, 2, 4. This should be the this. Okay. So position, 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 current position, current 1, 3, 2, 4, 5. Position, position, current, nothing, current, just 5. 2, 5. Where is the position? Position. Swipe it out. Now again, you have to check like if it is odd, if it is even, दो दो चार दो छः दो आठ, even 2, 3, 4, 5, 6, 7, 8, 8. What we have to do? Like position and current. This position and current is this two and the position, position and current, position and current. Okay, position. Now position and current. So one the position should be here. Now position should be here. 1, 2, 3, 4, 5, 6, 7, 8. 3, 5, 4, 2, 6, 6, 7, 8. Position should be here and current should be where? 1, 2, 3, 4, 5, 6, sorry, 6, 7, 8. Position should be, current should be, position should be here and current should be here. We are reversing. Now we move to backward like the 6. So there is no doubt we have to swap this one. Now we have to just swap it out like the 7. Okay, 7 and the 4. A1 and 4. Now again the position become like here. So it's the position 2. Now again the third, nothing. Just the position should be the fourth position. Now 2. So it's more like 6, 4. Uh, just swapping it out like data structure. Yes, this one. 1, 3, 5, 7, 2, 6, 4, 8. Now again we have to take a position. It's a 2. Like if this made this now 2, 6, 4, 8. Now it's 1, 2, 3, 4. So it's odd. So it's a 2 odd. Okay, good position. Now it's move forward. Mm, like nothing. It's a position. So it's position here. Now it's odd. So it's 4. Now 6, 6. This one is good. Now next position should be the this 2, 3, 4, 5. So its position is here. So its position is here like 1, 3, 2, 4, and 5. Yeah, sorry. 1, 3, 5, 4, 2. Yeah, you're right. 4, 2. So its position like if it is odd, if it is odd, like the position, what should be the position like? Where should be the odd value? 1, 2, 3, 4, 5, 6, 7, 8. What should be? 8. If it is odd value, you have to again take a rest. Otherwise, you have to take a like this value is should be odd, right? 2 to the also. Okay, okay. Mm, what you have to do, like if the if the odd if the odd if the odd is 1, you have to just swap what swap the position value. Position could be there. Position next. Position position value and position next value, right? You have to just swap it out if it is odd. Else, what we have to do? Make a odd, make a odd again one, and while the position is present, you have to just take like a swap it out. Swipe. If the odd is odd, you have to just swap it out. What? Swap it out like a position value, position value, and the header, like p value, and p should be the p next, and odd plus, and the position value should be the position next. Oh, sorry, next. Oh, sorry, next. Return the head, and also here made a list node. P should be position value. P should be position value. Now let's see. This passes all the pictures to Patna. Like 1, 2, 3. So you have odd value. This should be this. Then what to do? Like Why this fails? Why this fails? Position should be next. Mhm. Why this should be not fail, right? Why this should not pass in the test cases like 2 and 4, 4 2, right? So we are just swapping the position should be. Oh, okay. Let's just let's just try to print out first the position value, right? Well, let's try to print right position value. Like where should be the position? Position should be value 4. Okay. Position should be value should be 1. Okay. This one is good. Great. 1, 2, 3, 4, 5, 6, 7. Hmm. Now I get it why it is happening. Position value is 2. Okay. This position is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So what should be the position value? Like 8, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 3, 5, 7, right? So position value should be the yes, position value is correct. Position value is correct, right? Here this is good. Here oh, is this the odd number? No, even number? Yes, position value should be 1. Why 1? 2, 1, 3, like 2, 3, 6, and 7. Okay, 3 and go to position value is 1. Now we have to take the like this much. Let's see. We are swapping. This one swapping, this one swapping. Then again this 1, 3, 5. The index could be 2. Again the 2 and 2, 4. Index would be 3. Okay, 2 and 3. Now 2 and 3. 2, 3, 4. Index would be the 2 to 8. So it's like 1, 3, 5, 7, 4, 4. Hmm. Not get it. Why? Just take a na. Take index. Take index. Index would be what? Index would be 1. And just index plus plus. And try to print it. Giving the space. Index. Right. Why? Okay. 0, 1, 2, 3, 4. Yes, 4. Odd. 0, 1, 2, 3, 4. So like if it is even, you have to just swap it out like mm, take a test case like a one more test case like a 3. You have to just add like a 6. Just try to, I'm trying to do something right. Like 4. Yes, 4. So it's the 4, 1, 3, 5 and 4. Then it should be 2, 3, 4, right? If it odd, if it is odd, you have to just reverse the swap process. You have to just replace it. Uh, take the 9, 9, 9, 9. Take the 9, right? Take like one this add add. Just take a here 1 and 9, right? Like 5 the odd and the 4 the even. Just one value should be misplaced, right? Here one value should be misplaced. Oh, okay, all the values should be misplaced. Perfect. So what we have to do, like this much is good, this much is good, and this much you have to check by yourself because this much solution should be the okay. So what can I do here? Mm, So even on index, if we use the brute force approach, this much is solution, right? Let's try to different approach, right? Different algo. Let's try to different algo like can I do like can I do like linked list head all these good? Can I do most of procedures like how can we solve if it is taking we are taking like uh, making like a complexity data like what you are trying to do here like not to do like make a list of event indices or make a list of odd indices or just connect them and reverse return the answer. Can I do like this? Mm, mhm. Like list node, odd should be the head, yes, and list node, event should be the what? Head next, head next. This one is good. Head next, this one is good. While while the while the while the event is present, and the like even is present and even next is present. Even next is present. What you have to do? You have to just nothing to do. Like for odd next what? Like even next, even next, even next. Yes, and even right. And just move forward. Like odd should be the where? Like head 1, 2, 3, 4, 6. So it's odd. It's even. Now even this would this would this. So odd should be next. Now what should be the even? Even next should be the odd next, and even next should be the odd next, odd next, right? Odd next. Okay. Now Now what we have to do, like in the last, we reverse this. Now again we reached even next would be the even even next would be the odd next, right? Okay, even next should be odd next, and even even should be even next. This one good to this one. Now even we say even and odd here. Now again odd here, odd here, and even should be here. We are taking 6, right? Now again, so we just make like 6 4 and 6, and even should be here. Okay, 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 okay. So like we have to take a even here and take like a list node, event head. Head should be the head next, right? This should be the head next, and we reach to the final version. And what we have to do, like odd next should be the event head, event head, right? Event head, and return the odd, return the head or odd, return the head, just head. Yes, this passes all the test cases. Let's try to submit it out. Internal error. Okay, okay, okay. If the head is not present, or the head next, is not present, you have to just return the head, right? You have to just return the head, right? So this would pass all the test cases. I think. Okay, again not. Okay, okay, not present, but not present. So this would pass all the test cases. Yes. So this one, good. Let's move to next question. Segregate it even. Remove the nth load from the back of the linked list. Okay, back of the linked list. I can. Today I am going to solve all this problem, right? Because we have to solve 23, 23 we have to solve this, 24 we have to solve 3, and from the 25 we have to start like graph structure, right? Graph. Okay, so I'm going to solve all this problem today. So let's solve this problem, right? Remove n node from the list of, okay. And so first approach is like what, going to nth position and just removing that, like first position from the last that means like from the last 1 2 3 4 5. The one approach is like finding the length of the list, and n minus 1, thus. So just like this. Yeah, yeah, I'm trying to solve, like I wanted to tell you like I previously I give the context, like I am able to solve the previous my contest. Let me solve my contest. I solve the third question, like in the I solve all the problems, right? So I'm going to tell you, but let's first solve this one problem. English, remove the annular strip. You have to just remove the. Can I use the faster pointer answer? We can't use. So English like n remove the nth position from the last. So let's go add to nth. So it's like a data structure we can use. First, we have to count the list, all the list numbers. Okay, and nf, find the nf character. Okay, okay, 1110, 0, 0. Oh, there is a purpose. First, in the length of length ll 0, in the list list node head 1 is equal to head while head 1 present, you have to just length ll plus plus and the and what head 1 should be head 1 next this one. Now just length ll minus 1 is equal to, and if it is this length 1 2 3 4 5 5. So length ll, if it is 0, you have to just return the null value, null ptr. Yeah, null ptr, right? 1 2 3 4 5 6, sorry, 1 2 3 4 5 6, 1 2 3 4 5 6. Now we get it. Now we have to take quite travel. So list list node list node previous, it's equal to list node what previous should be null. Okay, and the current should be, oh sorry, head 1 should be head 1 should be head. Okay, now while or not while, take a loop, int is equal to 0, int is equal to length ll plus plus previous should be the head 1, and head 1 should be the equal to head head next, right? We reach the destination, like in this position we have 1 2 3 4 5, so 3 starting from 0. The previous should be the current, and current should be the 1 2. Now again in one position we have 1 and 2, so the two position we have 3 and 4. Now the that means head is pointing the deleting node, and previous should be this. So that means we have to just previous next should be the head 1 next, and return the head. List node. How can you make the mistake? This passes all the test cases. Let's try to submit it out. If this passes all the test cases or not. Not giving the wrong answer. Why? 1 2 and 1 0. Expected 0. What? Huh? Sorry. 2 minus 2 0. So you have to just return the. Okay. If it is become the null, you have to just remove the like the question now is this is the edge case. Wow. Like 2 minus 2, it's become 0. You have to erase the 0. Previous first case, first case, if it is 0, this will become the minus. If it is null, you have to if the if it is 0, if it is 0, if it is 0, length is equal to length is equal to LL is equal to 0, you have to return the head. If it is 0, if it is 0, so like if it is 0, if it is length, 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 LL, it's 0. If it is 0, right, length, LL 0, right. If it is 0, if it is 0, it's become 0. Not 0. You have to just find like a data structure like first you have find length and it's if just try to do like this. If length minus LL minus N is 0 and if the length LL if length LL is equal to N, you have to return to the uh, 0 and if the if the if the length LL is equal to 1, you have to just return the null value, null PTR, else you have to return the return the at next value, at next value. List node a solution undefined behavior. Why? Undefined behavior program where we are returning now. Okay. We are just making a mistake here. I think this can solve all. Yes, let's try to submit it out. Is it correct or not? Or is this yes, it passes all the test cases. So there is a edge case like this. If it is node is 1, you have to delete all node and you have to return the 0. So now let's move the next question. For the LL, given the head of the linked list, return the list after the sorting it in ascending order. Okay. So there is a, you can use the brute force approach like storing in the vector and sorting and again making a. Okay. I'm not going to solve that way. So how can I solving this out? Let's go 2 1 3. So, so, okay. Like so making like connection. This making like connection. Currently, this was given. what we can do here, we have to just return the value of, right, what you can do. If you want to solve using the linked list, only linked list, we have any another option, like what to do. Let's try to submit it up. So what we have to do, like 4 2 1 3 1 2 3 4. So sorting sorting using brute force, that might be right answer. But how can we use optimally like a 4 2 1 3? So if we're making like a 1 3 descending, not now. That is not a good solution. That's not a good solution. They use like 4 is first the good answer. Now 2 is good answer. We are making this. Now 1 is good answer. We are making this. Now we have again a list. Come 3. There is third 3, then it's 3. It's a travel. It's an square solution. If you are thinking like that, like, so it's not gonna work because the number of nodes in the list is 0 2 and minus 1 5. So it's not gonna work, right? And as the solution, like you are trying to insert the incorrect position, this is not gonna work. How can we do it? Use the merge sort in English. Can I do like that? Yes, sir. 4 1 3, right? 4 or 2, sort it out. 2 4. Now 1 and 3, sort it out. Now again sort it out. So and a login. Yeah, this can be passed. I think and login. So do you know the data structure used? How can we um, like merge sort merge sort in English? Can I do merge merge sort for English? Let's see. Okay. Can I do like that? Okay. 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 Split. Okay. Merge. Okay. Merge sort. Okay. Return merge. We can do, but it's a bit hard code. Like split, we are splitting. Consent to split English into two half. Now again the merge to English in sorted order. Now we have to. It's a complicated question. It's a complicated if we use the merge code, right? So any another what we can do, like sort. What should be the mm, like Can I use the can I use? This is the best question. Like I can use the merge sort here. Let's try. Let's try with that. It's my first time to writing a merge sort for the list. Like oh, what we can do here. Like what we can do here. So let's try. Let's try to write the code for the merge sort, right? So first we have mm, like if the head is not present, head is not present, or the head next is not present, right? Head not next is not present. You have to just return the right. You have to just return the null PTR or null value. Mm, null PTR, right? And what we have to do now? Just find the middle value. How can we first find the list node, slow pointer, take a temp should be null, and the slow is equal to head, and the fast should be equal to head, right? While while the fast and the fast next should be present. So temp should be slow, and slow should be slow slow next, right? And the fast should be fast next. We find the middle value, and so take a list node, take a list L1 L1 L1, like call the merge, sorry, call the short list, call the recursive function, right? Call the recursive function temp next will be null ptr temp quality है उसके बाद से, and we have to call the list node L1. L1 should be what? L2 here, L2 ले लो, L2 what should we call? And just call the merge value, like L1 and L2. Now the function arrive, like how to call the merge function, like list node merge, list node merge, sorry, L1, and list node L2. Now what we have to do, like how can you approach like this? So make a function, like make a value list node new node new node, new, and list, list node, 0, 0, right? Now what we have to do? Like while, sorry, while L1 and L2 are present, you have to just match the value. If L1 value greater than the L2 value, greater than the value, what do you have to do? What you have to do? L1 to so new node next should be new next should be new new list node L1 new node next should be like list list node current should be current will should be new node and current 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 next should be L2 current next should be if its value is greater than the L2, so L2 is smaller, so L2 and make L2 move to make L2 right make L2 to L2 L2 dot L2 dot next now again L2 as next else else current else current and next should be L1 and L1 should be L1 next, right? Now the question arises like how can we move? Like move L1 should be present current current next L1 and next should be L1 and L1 should be L1 next, right? Next, okay, while L2 is present, you have to just current next should be okay. We are not moving the next, right? You have to move next also. You have to move next also. Like here, you have to move current is equal to current next. Right? You have to move just like this. Move current should be current next, right? And L2 should be L2 next and L2 next and current should be current next current next. Now you have to just return the new node dot next. This one, let's try submit it out. It's giving the wrong answer for this. Why is giving the wrong answer? L2 L2 next L2 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 L2. Two first pointers. This return should be return null PTR, not a null PTR but a head. Head. This should be the hard first. This should be present first. So first, okay. I'm calling the L1 for temp and the calling L1. Okay, not a temp, bro. Not a temp, but a head now. You are calling the temp. You have to call the head now. Okay, yes. From the head. Yes. Yes. Trying to solve the time. Yes, this passes all the test cases. Yes. For parallel using the merge sort. I sort the main, right? Now let's move the next question. So now let's move sort the linked list of 0, 1. Sort the list. You can use the same approach like a merge sort. You can use the same approach of merge sort, right? What can I do? Like, can I use the pointer approach just like we are using? Mm, what like 3 pointer approach, right? Like one aimed. Okay, no, we can't use because it's singly list, linked list. We can't use. So what we have to do? Just copy from here, and we can use the same approach here. We can use the same approach here, right? Same approach of linked list solving because the time complexity is 10 to power side. So the log n values. uh, yeah, So log 10 is 6 should be 10 is 6 logs 10 is 6 should be 6, right? Okay, log is 6 like yeah, what is the value? It's the 4. Yeah, you can solve it out. So it can solve. So its maximum goes to like 2 into 10 to the power. Like, so you can use the same approach of this merge sort algorithm, right? You can solve it out using the merge sort algorithm. So I'm not going to solve this because this is same approach, right? We have to write this again. Let me just copy from here. Let me just show you. Just copy from here and just list node. You have to just node. Just remove the list. Just take a node, right? New node, current, next, current, nothing node, list node. Just remove the node, new node. Just remove this. New node, list node, list node, low pass enter, load, list node, sorry, list node, list node, and call the answer. Now call the return the shortlist. What is the this function called? Copy from here, just paste here, and try to drive and here. Compiler the node and structure. Okay, so it's like a data. So you have to do here value. Oh, sorry, data, data, and also I don't think. Uh, mm, mm, yes, just submit it out. Look, if you want to learn the sorting algorithm, you have to learn the merge sort, right? Because the merge sort is right. Merge sort is the best algorithm because it's worst and best time complexity and space is fixed. Right. This one is good. Now just remove it out. Now let's find the intersection point of LL. This one is good. One of my seniors who have given in the interview, this question is asked. No. This one not. The question is asked like the question asks the question asks like not. Yeah, this is same the question is. They are given the tooling list head and head with okay. Return the node at which tooling list intersects. Okay. What we have to do here? What we have to do here? Use that flag algorithm. What is this? I don't got this. Touch flag flag algorithm. What is this? Okay. Yeah. You can't use that. That's because that is the single English, right? You can use the here, right? In the array you can use the array that you can use the here. I already solved this problem using that algorithm, but I don't know the name. Yeah, I just name it the three pointer approach, right? So this one. I solved it up. But you can't use in the single English because there is no way you can go backward, right? That's why. So what we have to do, we have to solve this question. So this one is like one. Let's suppose take a faster and no, not a faster. Y intersection, right? Okay. Let's cycle. Given two English are intersections, it's return one. For example, the English. Okay. 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 So the solution of this code, like first think like in this algorithm, like in this way. That first make the cycle, right? First go. We make the cycle here to here, right? Make a cycle. Now we have to just find the. Like, no, we can't make that. Yeah, we can make a cycle, right? From here to here, we can connect the last index to first. Now we have to find the cycle. If there is no cycle, yeah, you can cycle the skip to cycle one and skip to. No, what is a skip? What is a skip? There two and there is no cycle anywhere in list. That case is such a note as a list must return only natural return. But come there is a list not second not we have to through intersection it. Intersection at one intersection. Taking no intersection. If you make that like we have to move, just take a one PMN. We are taking right first. If we make that this one all together, right? Sorry for the noise. Let me first close the door, right? So if we connect the list one, any list with the right with the first and the person, it should be cycle. So now we have to just go to the grid view. Like head one, head two, head B. If we are moving like connecting to and make a cycle, and we are head one. So we are moving like a head two. So it's slow, fast, slow, fast. Okay, fast, slow, fast. No, if you can't do it, you can't do it. Right? So take a fast and slow, not a approach, but do the approach. But, like disconnect 4, 4, 1, 8, 8, 5, connect to, connect to, connect like 5, 6, 6, 6, and 1, and 1, connect to this, right? This one, this one is all connected, right? And this one is connected. So it's a cycle. Now we have to just move like a slow pointer and the fast pointer. Slow go here, fast go here, slow go here, fast go here, and slow go here, fast go here, fast go here. Okay, okay, yes. And now the slow goes here, slow goes here, fast goes here. Now slow goes, slow goes here, fast goes here, fast goes here. So we can just traveling out and making. If the slow and fast is matched, we have to just go cam is equal to head, any head, any head, and slow. If the both are correct, we have to just later. Right. Just take right 1, 1, 8, 4, 5, right? 5, 6, 1, connect to this and connect to this. Now slow, fast, slow, fast, slow, fast. Mm, okay, slow, 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 fast, slow, fast, slow, fast, slow, fast, fast. So, यहाँ slow था, fast, slow, slow, fast. Sorry, fast. Now slow, slow, fast, slow. We can't meet it out. Wait, can't meet. So what we have to do? Mm, we can't meet. So we have to just make a circle. Right. What we can do here, like finding the first approach, like mm, mm, I think we can use like find the intersection y in this. Uh, find the find the intersection intersection in Y, find Y, list, list, list. Found the number of intersections. I think I there is a good question, but this one is easy, right? Like why this one is easy problem, right? Like list node, take a h1 should be the head one, and take a h2 should be the, oh, sorry, should be the head two. This one, now this, right? And while h1 h1 is not equal to h2, you have to just take like age present. You have to just take like h1 is present, so h1 is present. Then you have to just move the h1. Next, else you have to just swap it out, like h2 or h2 is present. Sorry, h2 is present. H2 next, or head one, right? And I have the one. No, the h1. Why are you taking? And the one approach like one is approach like using the circle, right? I solved using this, but I can't swap intersection in voice application. But if I didn't, I can. Yes, yes, yes. I solved using this, right? It's a hash map function. Sorry. Yes, I forgot that. Like, let's see. We are moving to the last index and making the last index to making the loop, making the loop. And now we have to check like if the break fast, we have to break. Otherwise, if not it, we have to return false. Right? We have to just return the false if it is false not it. And now true and false, we have to just return the true. This one is good. Third one, head two. Just this one is good. This could be also good. This passes all the test cases, I think. Right. What I am trying to do is we are going this, and we are going this. If the head is present, we have to use the head. If the head is not present, you have to head to, right? Just swapping the values. And this one is also good, right? You have to just take care of this. Like we have slow here, else the faster move matching like somewhere I missed, right? We have to miss. If we take the head two first and connect to head one, so slow pointer should be head one, right? Slow pointer should be head two. Fast pointer should be head two, right? If we are connected to head one and head two, we have to use the head one. And what about that, right? So just take it out. This is good approach, and you can use another approach like mine approach. So my approach like, can I do like that? Like one. We are traveling like so one, not equal to. So moving to next, moving to moving to next, moving to next, moving to out of door. So it's a one. It's the next. Step. Okay. It's out there. So A should be here, and moving to next. This should be this. Now moving next and next. This should be this, right? This should be this. So it's like that same. You have done to use the like this graphical approach, like right. You have to just see the elbow how to use. So this I solved and the point, right? And what I'm trying to do, like how can we solve it? I using the making node and node. You have to don't you make the node, right? Like I solve it like let's say just h1. H1 should be the head one, and the h2 should be the head two. What I'm doing here, like what I'm doing here, sorry, h1 is not equal to h2. What I'm trying to do here, like see, we are present in a 4 and we are presenting in h2 in 5. So we are moving on forward. If if the any index is like any index reverse that out of the board, like 4 out from the 5, you have to just return to the like reverse. A should be the 9 and if A should be the become B and swap the indexes, right? This one, that's why we are using. And if you are using like if you are thinking like why can't why we are doing this, we have to just take like the uh, like h1 next should be present, right? Next should be present. So h1 next this and the h1 h1 next should be next should be like head one. This become the loop, like this become the loop up now the list node pointer slope is should be the head 2 and the pointer fast should be the head 2 head 2, right? Now while the and fast the fast next should be present, then we have to just slow is equal to slow next and the fast next should be next, right? What we have to do like here, if we found like slow is equal to fast, what we have to do, we have to just break out from here, right? Break out from here. You have to this not null, not a breakdown. Just take a like return the null. If it is, so we have to just move like a slow is equal to head to. Now while the slow is slow is not equal to the fast, you have to just return the, you have to just like slow, 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 slow is equal to slow next, and fast is equal to fast next, right? And just you have to return the slow. Compiler error return the, okay, null ptr. This is giving the wrong answer. Intersection error linked list modify. Huh? Okay, you don't have right to modify. In this question, you have to right to modify the linked list. Right. So in this question, you have to don't write have like error linked list structure was modified. You can't modify, right? So same approach you used without the modifying the approach. Like head one and head should be equal, right? So what should be the linked list? Like while same approach I solved using that like first approach without modifying, right? This approach. In this question, we have to full right to modify that, right? Not in this question. It's conserve you have to compare it according to what chemical whatever. Okay, now next, let's move the next question. Like add one to the binary linked list whatever. What we can do here? We have to just reverse the answer. First reverse the linked list 6 6 5, and then again reverse. Like node reverse reverse list node head node previous null null previous null. Now what we have to do? Now it's a 3 hour. I'm doing DSA 3 hour. Okay, okay. I have to just solve two more questions, right? Then I'm going to that paper. Previous and the current head head. Like while the current should be present, and the now take a temp temp करंट डाल देते हैं and the करंट को करंट के नेक्स्ट मूव करवा देते हैं. उसके बाद फिर क्या होता है? उसके बाद प्रीवियस temp, उसके बाद temp नेक्स्ट में temp नेक्स्ट में प्रीवियस प्रूफ करवा देते हैं। एंड प्रीवियस में करंट डाल देते हैं। like 1 2 3 4 5 1 2 3 4 5. So we are like the previous is equal to here, we are here. Now current should be here. Yes, so temp should be here and current should be here. Current temp here, we are making that. Now current should be here, temp here, we are making that. We are making that, we are making that, we are making that, right? And previous should be temp. Previous should be not a temp. Previous should be temp and return the previous. This return the current should be here and temp should be here. Like this, previous should be now current should be here. We can't go outside like this. Current should be here. Now temp is here. Now first we have just write the reverse answer, right? Now first made a node like reverse node, reverse node, reverse, reverse, reverse list, last not a list, list head. Now we have to take a carry is equal to 0 and carry is equal to 0. Now while the head is present, sorry, not a head but a reverse. Take a node head 1 and its reverse. Now let's suppose if the carry plus the head 1 data is equal to 10. If it is become the 10, you have to just take like head data should be 0 and carry is equal to 1. Else head 1 data should be carry plus head 1 data and carry should be 0. And moving forward, head 1 is equal to head 1 next, right? Next. Now what we have to do here, just take a head 1. Now this all reversing like 10 is equal to 0, so you have to just say 9. Now it's like 10 1 plus 10. Okay. Always take a carry, right? Carry should be 1. Now like the 999. So 1, if the data plus 1 is 10, carry 1. Okay. This all good. Now, if the carry is present, we have to make a new node. New node is equal to new node 1. And what? Add nodes to the new node and just return the reverse list of what what reverse. Are you sure this one is good? Yeah, I think this should pass all the discussion. Let's see. What's English? I think we made a mistake using English. Okay. No. Just giving the right answer, right? Let's put it right. Ability now. Okay. So the one reverse sign, reverse head, data plus one. So head data 9, 10, carry one. Okay, okay. Like head is present, head data plus one, head data is equal to 0. Yes, head data. Okay, we have to take a previous element, right? We have to take a previous. We have to take a previous. इसको हम लोग null value बोलते हैं and just previous को हम लोग head 1 डालना होगा and just previous go next one. Now custom input take a 9 9 9 10 it's 100 now. It is the reverse element is returning not a correct, right? Like 9 9 we are presenting the previous null. Temp is here, current should be here, this should be this. Temp dot next is equal to previous. Why this question is like a wrong answer? Why this emoji is bit low, my? It's version not null is not correct, right? What we have to do here? Just reversing the value and the that, that's what we have to do. Just to do like head one should be the carry 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 plus head one data. Take as carry plus head one data and the head one data should be as modulo 10, right? And carry will be s divided by 10, right? Yes, this passes all the test cases. Like why my code is failed first condition, second condition. Why this? I think this one is correct, right? Why this? Query should be 1. So we can use like a take up previous, right? Previous null. Previous is equal to head 1. So next question should be either adding two numbers of English. This is a good question. This 9 किसका है carry should be 0 now carry should be 0. Why this could be not running, right? Data is equal to 0, carry is equal to 1. If it is 10, if we contain, we have to just make a head 0 and carry 1. Why this not giving right answer? I don't understand why this. Like, Why this just give the fucking which is like 10 plus 9 is equal to 10, then we have to just do this. Mm, it's the bug in damn current, bro. The fucking just why this like carry plus 1 data is equal to 10 and carry plus jet. All this is good. Oh, sorry, sorry. Carry plus 8 data is equal to 10. Just see the solution of others, right? One of my solution, right? It's a reverse. Okay. Good one. Ah, let me fucking bitch. Okay. Mm. Next I'm going to ask from Gemini, right? Why this why this one giving the wrong answer? Like, why this give the wrong answer? Let me ask from the Gemini. Tell me why this is wrong answer. Hey, what happened, bro? नेटवा नहीं चल रहा क्या? Must sleep correct, but there are some few edge cases platforms. अच्छा, if like responses. Previously ये सही है reverse वाला. It will not. ऐसे edge के संबंध के. Previous not सही है. सही है. Carry 10 हो गया. Then previous hey, ये break करके आ रहा है, right? ये यार previous रहेगा तो 10-0. Yes. फाइनल फाइनल स्टेज पे हम खड़े हुए हैं. प्रीवियस डॉट नेक्स्ट को न्यू नोड में डाल दिए वन है। Why not just just ये नल क्यों दे दे रहा है यार, ये तो पास इसमें पास क्यों नहीं हो रहा। हाँ समटाइम तो यहाँ पे हम लोग कर रहे हैं क्या, कैरी प्लस 10 इक्वल टू नॉट डेटा, यहाँ नहीं हो रहा क्या, ग्रेटर देन 10 बोल रहा है क्या। अच्छा ग्रेटर देन इक्वल टू 10 बोल रहा था। यस दैट्स व्हाई दिस गिविंग द रॉन्ग आंसर। 10 100 होगा ना। Awesome. That's one. This much only error and this fucking bitch. Yeah, इतना नहीं सुन पा रहा। 8 2 number. The question now, the last question of the day, like 8 2 number of the list. I solved all these problems. Now, given you are given two empty and a string work, you have to just reverse all this string, right? We can reverse all the string. Reverse both the string. Now we have to just add like what we have to do. 4 3 4 2 4 6 5. It's a 7, so it's a 7 and carry 0. Now again carry, it's a 10, so it's like a 10 a 0. It's carry 1, carry 1. Now we have to reverse. Same solution, same solution of previous one, like add 1, add 1 to DLL, same solution. Just we have to just copy from the here list node, paste here. You have to just add here list node, right? List node, list node, list node, previous list node, list node, list node. Okay, just now we have to call the list node, list node, list node, L1, river L1 is equal to L1, again river L2 is equal to for L2. Now we have to just take a carry should be 0. Now what, just while the river L1 should be present and river L2 should be present. Now what we have to do, int the sum is equal to L1 sorry, river L1 value plus river L2 plus carry. What we have to do, we have to just take a new node, nice. We have to just take a new node. We can't use the same node. Can I use the same node? You have to take a new node, right? Take a list node, new node is equal to new list node is equal to 0. Make list node and current should be new node. Okay. just current. Can I give that them to L1? The L1 value should be sum and carry. Can I do that like that? You can do it like, but what if something else like L1 is smaller? You have to check like L1 is smaller, so you this is not a good approach, right? Okay, next, this mm, just put it up and new list node, list node sum. Okay, and uh, and the carry should be sum, not loaded. Now current should be next one and reverse. Current should be next and reverse. L1 should be reverse. L1, L1 next, next and reverse. L2 should be reverse. L2 dot next. Right. This one is good. Now we have to just take it out like while reverse, reverse L2, L1 is present. We have to just take a sum is equal to L1 value plus carry, and the current should be, sorry, current next should be the new node, list node, and the sum modulo 10, or the carry should be, and the carry should be sum divided by 10, and the current next. Okay, and L1 should be, and reverse should L1 should be reverse next. Same goes for like L2, reverse L2, just copy from here, just take L2, L2, L2. Now final version, just carry is present. You have to just take like a current next one is equal to what you have to do. Leave list node, list node 1. Okay, and the current should be current next. Now return the reverse list, calling should be new node next. Hmm. Int value. Okay. It is giving the wrong answer. So I say, okay, it is not reversing. Sometimes also it's not reversing. Why? We have this. Reverse now. Yes, reverse. New node. List. Return the answer. This should return the answer, huh? Final version is not reversing. Why? Just call the name, like call the for the I will say call the next node then. Not call the reverse. Okay. Huh? Okay. Seven, 0, 8, 8, 2, 4, 6. 5, 6, 4, 9. Okay. Reverse the number. 9, 4, 6, 5. And the 9, 2, 4. Yes. Like 2, 4, 9 and 5, 6, 4, 9. What is the question suggest that? You are given non-empty list of representatives. These numbers are stored in reverse order. Acha, reverse. Okay, reverse order. You have to just sort it out. 2, 5, 9, 4, 4, 6, 5. And we have to just 9, 2, 4. 9, 8, 10, 2, 4, 9. Okay, okay, okay. What? What you have to do? Krishna. Another one. Very good. Right. Just keep this and follow the instruction. Follow the next. Node. Next. एक बात नहीं डरता. Okay. You have to just return. No reversing. No reverse required, right? You have to just return. End to end. Into sum. L1 into. X node, new node, carried. All the case cases should be passed like it passes its tail. Why? It's like 2, 4, 9, 5, 6, 4, 9. It's A1, it's a 0, 1, 4, and 1. 4 and 1. It's 1, 1, and carry 1. So it's like a 0, 10, 10, 10, 10, 10, 10. Let's not, let's. Why this fail? Can I write like why this fails? List node, current node, all road. From L to okay, yes. I made a mistake here. And go reverse and go reverse and go. Yes, this is called expression. Yes. So there no need to write a travel. This code. Right. You have to just do this back. Let's see the POTT problem. I solved all these problems, right? Maximum number of balloons. You are given the text. You want to use the character of text to form a meaning in instances of a word balloon as possible. You can use its character text at most once. This character return the maximum number of extensions of the balloon. Okay. Balloon. BALL. Oh, you want balloon. Huh? What is it? Well, it is you want to use the character of text to for as many instances of the balloon as possible. Okay. So BA. Okay. BALL. OON. And this character we have BOL. Okay. BOL. Ball. No. And LA. And LA. So you have to just take a balloon and all the characters which is presented here. Like a ball. Like a ball. Here we have LA and present L, present A, present BO, L, present. What we have to do here? Mm, Given the string text, you want to use the character of text to form as many instances of word balloon. Loon. like one. DOL. Okay, okay, okay. Just store the all the indices and check for the answer like vector int count 26 0 travel all the way x and the count x minus a plus plus, right. uh, Travel x balloon balloon all character should be present, like L should be present more time, B should be present, all the characters should be present, and L should be present two times. This not check, right? If the count of B, like hmm, what we have to do here, we have to just see like if all the characters should be present. First we have to check like all the characters should be present, and for L it should be 2, and for O it should be like what we have to do, like find the minimum, say 1e9, find the minimum, what, not a maximum but a minimum, and take a also take a balloon, uh, check like if the count of a minus x is present greater than is else also, and the count of sorry the count of L should be greater than equal to 2, and that the count of N O minus 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 A should be greater than 2. Okay, then we have to just minimum the minimum of count of count of x x minus 8, right, for a minimum, right. Else what we have to, else else just return to 0 and return the minimum. Let's try to do what GC. Why this? Some kind of joke. Why this giving the GC? Take it. What we have to do here? So what we have to do? Why is it giving the wrong answer? Let's let's do like return minimum of what? Count B, count B minus A, and the count B minus, sorry, A minus A, and the count B, count balloon L minus A divided by 2, and the count O minus A divided by 2. Now count N, right? This one is it. Now just return the value. What is it? No, not a semicolon, right? It's a semicolon, right? Yes. Accept this. Is this? Why additional object? Why this is the solution not? We have to just yeah, balloon, right? Why this giving the wrong answer? Okay, okay, sorry. 26. This would be this. What 0? B is present. Okay. A is present. Okay, 1. O is present. Okay, 1. N is present. 1. O is 2 times. 2 times. L is 2 times. 2 times. Greater than equal to 2 times. And A is greater than 1 times. Okay, 1 times. B is present. Yes, B is 1 time and L and 2 times. Oh, it's present. Oh, 5. Okay, okay. Hmm. Okay. So first one is good one. I think we have missed something in this approach. This one is good. Let's complete this. So this one. So thank you. Let's end this.